Hi everyone, this is the first lesson on kinematics. It's all about accelerations and distances and velocities. The first section we're going to have a look at are graphs in kinematics. These are mostly going to be distance time graphs and velocity time graphs. You'll probably have seen them before at GCSE physics and maybe GCSE maths as well. So some of this will be familiar to you, but we extend the idea a little bit further, especially on velocity time graphs where we have to do some slightly complicated stuff. Mostly to do with figuring out distances travelled. We'll do some examples of that later in the lesson. So this is what we're going to cover. We'll have a look at distance time graphs first, then velocity time graphs, and then we're going to look at calculating distance on a velocity time graph, which is normally what we get asked to do in the exam. And we'll finish off with a practice question at the end so you can see the sort of style of question you might get asked in the mechanics exam. So let's start with distance time graphs. So here's an example distance time graph with a load of different sections, and we're just going to label each section and talk about what's happening. So what's going on here? This is a constant velocity. Okay, so how we find the velocity from a distance time graph is we look at the gradient. So we'd measure the change in distance from here to here, and the change in time from here to here. So this is the change in distance, this is the change in time, and then we'd divide the distance by the time. That would give us the velocity. So if you have a straight line on a distance time graph, you've got a constant velocity. This section here is a flat line. Now the distance isn't changing along this flat line. If the distance isn't changing, then you must be static, okay, or stationary. So the velocity is zero effectively because we're not traveling any distance. We've got another constant velocity section here, but have a look at the gradient. Can you see the gradient is lower on this line than it was on the first line? So this is a lower velocity than this one, okay? Because it's got a lower gradient. The change in distance is much smaller compared to the other one. So if you figured out the change in distance over the change in time here, you'd see that the speed is a lot lower for this section. We're stationary again here. Here we've got constant velocity again, but can you see how the line is actually heading back towards zero? So actually this is going backwards. Okay, so it's a constant velocity, but we're heading back towards wherever we started. So we're heading back towards what is the origin here, back towards our starting point. And then this last section of here, it's a curve, which means we've actually got an acceleration. So on a distance time graph, a curve means we have an acceleration, okay? And an upward sloping curve means an acceleration. A decreasing slope of curve means a deceleration. Okay, so this one is starting at a low velocity, so we've got low velocity here, and high velocity up here. You can see the gradient's much higher near the top. So we've got an acceleration from low velocity to high velocity. A curve that starts steep and gets shallower is a deceleration from high velocity to low velocity. So just a quick summary of that. The velocity is the gradient of a line on the distance time graph. So we can write that as v is delta d over delta t, or note that we sometimes use delta s for distance. Okay, so you might see it written like that. You'll see s used for displacement quite a lot in the next few sections, okay, especially in the constant acceleration lesson next time. And a curve is an acceleration or a deceleration, as we've just talked about.